think material science is a little bit different from most other engineering disciplines in the way that it really allows you to get at the building blocks of the way we make things and the way we test things and see things. So we really get to play Legos with the atoms and build up materials for specific applications with precision that other disciplines don't really get at or really take advantage of.
In material science, we're probing matter at or near the atomic scale. And so we need a precision in measurement and precision in manipulation and synthesis that is unprecedented, and that all requires huge investments in new modalities of measurement and new ways of manipulating and synthesizing matter.
Material scientists are the users of the technologies, and it's important that they have a hand in describing the features that they need in those instruments that characterize materials.
At Johns Hopkins University's Materials Characterization and Processing Facility, we've created a research space by material scientists for material scientists.
The MCP was Johns Hopkins' search for a central facility. The challenge was to make it beautiful, but also functional. Our hope was that this would be a place that would allow creativity to blossom.
The MCP has really broadened the reach that we can have with our research and the scope of the research that we can do.
We have some tremendous equipment for characterizing the microstructure of materials, which produces tremendous amounts of data. The MCP is really well equipped to generate that data, analyze that data, and then using machine learning tools and artificial intelligence to be able to take that and learn new things.
At the MCP, we're investing in a unified data management system at the petabyte scale that allows researchers to not worry about where the data is stored, how it's transferred, how to process all of it. We're also investing in compute infrastructure, so the data itself doesn't have to be transferred back and forth between researchers' computers or their workstations or wherever they prefer to compute.
In our facility, we have the first Grand Arm 2 from JEOL in the United States. It has very high resolution, 50 picometers resolution, and it has many attachments to it. Many of them allow us to do low-dose imaging that enable us to look at very beam-sensitive materials. We have all the bells and whistles for electron energy loss spectroscopy and different imaging modalities with electron detectors.
My group likes to measure unusual properties of materials and then look inside the material to see what gives it the special properties that it has. That's a tradition of material science research throughout, but we really like to go to extremes and extreme temperatures or extreme strain rates and really figure out what the unusual deformation mechanisms are. And so that's where the MCP is so advantageous here. It really lets us push the boundaries of what can be made and the new materials that we can discover and develop. And it also lets us really characterize materials across a range of scales.
We have had many people from universities, other governments like the Italian embassy and the French embassy come and visit us because they want to know how we designed our facility and essentially what our philosophy of design for the facility was.
Our facility is actually housed in an old silver factory. So we kind of took that as an inspiration in trying to reimagine the modern foundry. And so in doing so, we didn't want to build just a characterization center. We didn't want to build just a center where you would be making things. We wanted that to be integrated, and to tie those two pieces together, we have a really strong component of artificial intelligence and data science that allows us actually to, form a loop and an integrated interdisciplinary approach to making and understanding and developing and discovering new materials. So in that sense, I think really it should be seen as a forward-thinking way for us to even have kind of a lab of the future.
It's no coincidence that civilizations are defined by the materials that are used, like the Stone Age and the Iron Age. And now, whatever age we're in, it's really important to have the tools to develop and characterize those materials because they have an incredible impact on society. Here at Johns Hopkins University, we've got some incredible research going on that's being enabled by this materials characterization and processing facility. So we really have a materials at Hopkins brand that's growing and that is being facilitated by the instruments to process and to characterize materials here at the MCP.